In 5-4, you would think, based on what we did yesterday, because in 5-3, they gave you the shortcut and told you side angle side. So in today's lesson, you would think that they would give you the next shortcut, because I told you that that's what they're doing, is they're giving you like one a day. However, the next shortcut requires you to have another theorem to be able to use. For instance, in the next proof, in one of the next proofs, it's not a very good isosceles, but let's say this is an isosceles triangle, okay? They're going to do this to you, and they're going to ask you to prove that these two triangles are congruent. And the only thing you know is the outer one is isosceles. That's all you know. So after step 1, the only thing you'd probably be able to do is say that these two sides are equal. So whatever these sides are, AB is congruent to BC. You'd be able to say that based on, Ella, the definition of isosceles, correct? You'd be able to say this is reflexive, correct? Mm-hmm. So you'd have your reflexive step now. But what would you use to get that third piece? Because all of the shortcuts require 3 pieces. So you would have 2 sides, but you would need a third piece. And in the given, they don't tell you that this comes down perpendicular. They don't tell you that the bottom has been bisected. So there's no way to get this angle to be 90. There's no way to get this side to be congruent. And so you need the theorem for today's lesson. So you need this theorem down here. Other than that one theorem, the rest of this information, you don't really need for proofs, but you do need just to find values of the triangle, okay? So today's lesson to me seems very out of order. I almost feel like this lesson should have been like before they even mentioned proofs. They could have done it earlier, but me not teaching this course before, and I've been told they want us to use the book as it's written. I struggle with where this lesson falls in the chapter, okay? So today, they're not going to give you the next shortcut. They're going to give you a couple theorems that you probably already kind of know in the back of your head. You're probably like, oh yeah, those make sense. And then they're going to ask you a lot just to find x, find sides and angles. So it's just very numbered. The proofs will come back fairly heavy in 5-5 and 5-6. Okay? So first of all, this is an isosceles triangle. There's really only one main vocabulary word that you truly need, and that's called the base angles. But if you don't know some of the other vocabulary, you might not know what base angles are. So first of all, the pieces that are equal, do you know their vocabulary, what they're called? Like the 2 sides that are equal? No? Okay, they're called the legs. So the 2 equal sides are called legs. The non-equal side is called the base. Just be careful, because sometimes I'll get kids who think the bases means bottom, but what if your isosceles triangle was drawn upside down? Like what if it was drawn like this? Or what if the isosceles triangle is a right isosceles? So then this would be your base, this would be your base. So base doesn't necessarily mean bottom, okay? It's just the non-equal side. Then it makes sense where this goes. The base angles are the angles that form or touch the base, because those are the base angles. So that is probably the most important. They do use one more vocabulary word sometimes with isosceles, and that's vertex. So vertex is the piece that's made up from the legs. You have to remember, isosceles right, not this picture. but isosceles right triangles are the strongest ones. So that's why you see them pop up almost like as their own independent lesson sort of thing, okay? So down here, this theorem, you're going to need this in proofs. Remember how on the quiz here you just used right angle congruence theorem? You don't use it every day, but they expect you to remember them. So this is one of them you need. And it basically is very easy. It says if your triangle is isosceles, so if you're isosceles, then the base angles are congruent. So it's not difficult. It almost makes sense. But when you guys do this proof tomorrow, that's how you're going to tell me these two angles right here are equal. So then you'll be able to use one of the other shortcuts because we don't have side angle side. The angle is not included anymore, okay? So I know I'm skipping around, but it's not too hard. Just turn to the other page real quick. We'll come back to the rest on the front for a minute. Take a look at number 3. Really hard question. Isosceles triangle. Therefore, the base angles are, yeah, so then this is just 75. Done. So I don't think the problems today are that difficult, but they just want you to practice this theorem with numbers before they throw it into a proof. Take a look at number 4. If this is isosceles, these two corner angles are going to be equal. How are we going to get to find the actual number then? Help me out. How am I going to find that? Sadie?
Subtract 40 from 180.
Why?
Divide that because the total amount of angles in a triangle is 180.
Okay, so triangle sum theorem.
And then divide that by 2, and you'll get 70.
Correct. I really almost think that this lesson, 5.4, would have been better earlier in the chapter, like right after triangle sum theorem, because I feel like you use a ton of triangle sum theorem in this chapter, or in this lesson. So again, I don't agree with the order, but I didn't write the textbook. Take a look at number 5. Number 5, and you don't have to turn your page, just watch mine for a second, is the converse. You can fill this in a minute, but just think about what does the converse in general mean. Just the converse. Remember how we did converse, inverse, contrapositive? We did those 3. What is the converse? Where you do what? You just switch them, right? So if the what? So if the base angles are equal, then it's isosceles. No, we'll come back to that, but look right here at this triangle. These base angles are equal, aren't they? So that means this triangle is isosceles, correct? But these angles are also congruent over here, yes? Which means then this triangle is also isosceles. So then wouldn't these two pieces just be equal to each other? So just like you did on your quiz, I'm not saying you have to necessarily make an equation because some of you are pretty good at doing it in your head, but you just set the sides equal to each other and then finish it off. You're not going to see any systems today, but you will see some little one-step equations, that sort of thing. Okay? So let's fill these back in over here. I have used this in a proof. I'm trying to remember if it comes up in your chapter or just in general, but I definitely think this is one to think about. Base angle one is definitely used. It's not very often that they're going to tell you maybe this converse one in the proof. I just can't remember. So it's still good. We need to fill it in. So if the base angles are congruent, maybe we should say in a triangle. I think everybody hopefully should know if they're base angles because you don't really have base angles in a square or something like that. So if you have base angles in a triangle, then the triangle is isosceles, or you can just say isosceles if you don't want to be real specific, keep using the word triangle. So see if you can do number 2. I'll tell you right now, number 2, there's a question exactly like this on the test, only this picture has been like flipped over and it's got different letters on it and stuff like that. But this question, number 2, part A and B, it looks just like the quiz. The test. I was trying to get the test review done to maybe give to you on Friday just in case I don't see you again. I don't know. They sent a letter to your parents that says the health department's not real happy.
Oh no.
Yeah, I don't know. If you read the letter to your parents.
Didn't they say that they were going to be closed on Tuesday?
Don't know. I didn't say Tuesday, but it said
Those were the rumors.
soon.
This Tuesday is
It didn't say Tuesday in the letter, but it said cases continue over the weekend.
Well, it's something closed before the health department closes this week, so sports.
Yeah, it doesn't say Hudsonville's gonna close you down. It doesn't say anything about Hudsonville.
Well, I know, but
It
it's
says the health department.
Yeah, if they close us down, we don't have sports.
Correct.
And we're all really close to conference right now,
Correct.
so we're gonna need.
I'm just saying, part of me is thinking that if I can give you the paper copy, you know what I mean, then, if
For how long though? Just like 3 weeks?
It doesn't
If it's
say.
a month. For
It
the
doesn't
health
say.
department, it's usually 28 days.
in the letter, it's very vague. All I think it says is until cases go back down for a extended period. They used words that like, what does extended mean? Is extended 3 days, 2 weeks? Like, what is extended?
If you don't want school closed, then wear your mask over your nose.
It's very vague. It's actually, to be honest with you, I don't think it has anything to do with schools because all of our cases are not related to each other. Like the one person has no ties to the other people. So the cases that we've had are actually, they're picking it up from somewhere else.
But from what I've
And it's been
seen,
very
every person
contained.
I've seen say they don't want school closed, wears their mask if they're
It's so dumb.
I'm just saying, my point is I'm going to try to give you guys the review before you leave, just in case I don't see you again. Then you have the paper copy. Okay, here we go. Shh, ready? Shh, Ben, ready? I'm going to mark mine just because I'm such a visual person. If I don't mark it, then my brain like loses its train of thought. So, HG, HK. So I can see that's the isosceles triangle. So they really are asking me about these two corner angles then. Now, the one on the left, I can probably just say clearly G. Everybody knows where G is. But the one on the right side here, if I say K, you're not going to know which side of K it would be. So for this particular angle, you should use all 3 letters. So I'm going to say G, K, H. You can definitely say H, K, G. You can switch those first and third if you want. If it's all by itself, it's okay just to use the letter. But when it's kind of like that, one on each side. Okay, so then that was called the base angle theorem. And then this one, notice they're giving you the angles. So this is the converse. So if you know the base angles are equal, so that's this one, and that's this one. So if you know the base angles are equal, then this is isosceles. So they want you to state which sides are congruent. I don't care if you don't put the little line above it, but they just want you to say which sides are equal. Remember, the base angles go up to form the vertex. So K is the vertex. So that means that this is equal to this. So you just have to put your letters. HK, KJ. This question like this is exactly the same on the test. It's just this picture's been turned and it's like different letters. But it's the exact same question. Turn to the back. These two corollaries, I am not sure I've ever used in a proof, but if you don't pay attention to them, you won't be able to solve the bottom. But remember, a corollary is something that you kind of already know. Like you already know it, it's just they're stating it. So the first corollary basically is just telling you if you're equilateral, so if your sides are equal, then your angles are equal. Which makes sense because how else would the sides fit together if they're all the same? So take a look at number 6. This is marked as equilateral, correct? Which means then all of the angles are the same. So if you take 180 divided by 3, doesn't that mean each angle is 60? So then all you have to do is basically set this equal to 60. So 2x equals 60. You divide off the 2, and you're done. Again, not that you couldn't use a corollary in a proof, it's just corollaries are more just helpful to solve problems. So you don't have to like memorize the title. And then you know what the converse is again. You guys already told me the converse is when you switch it. So if you're equiangular, then you're equilateral. Take a look at number 7. If you were to find y first, you could probably try to find x first if you want, but I was just kind of thinking about this corollary. It's marked as equiangular, isn't it? Well, if it's equiangular, the corollary tells us then it's also equilateral. So then these two sides, even though it wasn't marked that way, 28 is equal to 4y, so then y is just 7. And then you can find x. Do you need me to help show you how to find x? Do you want me to finish this one off? Yeah? Okay. So this is equilateral. So these are all the same, correct? Which means that this is then 28 as well, because they're all 28. Look at this triangle now. Sometimes it's hard because it doesn't have letters on it. So this green triangle. Is this green triangle equilateral? No, but it's isosceles, which means the base angles are equal. We kind of need to know this vertex. Is there a way for me to get this vertex?
Yeah, you can do, like you add the angles in the equilateral thing, and then
I could. The only problem is I don't know what to add these. You know what I mean? Go here.
oh, okay.
How much is this angle? 60, right? Aren't these a linear pair? So 180 minus 60, that means this is 120, correct? If I take 180 minus 120, don't I only have 60 left over for this triangle? Which means that these are both 30. Now be careful that you don't tell me the answer is 30, because that's not what they're asking you for. This angle is 30. How much is x? 15. 2x equals 30, so you divide it off. These problems sometimes look like they're going to be a system because there's like x and y, but you want to solve one of them first, and you don't always necessarily, I mean, I could have done x first. I didn't need y to do x, but you just want to pick one of your variables and go for it, okay? So there's 2 more down here. I mean, how do you feel? Like, I'm happy to go over them. The answers are posted. Sometimes kids get a little bit tripped up on 9 because they see the x and y together and that freaks them out, like because it's in the same expression. This is not a system. You don't have to use a system on this. Do you want me to show you how to do 9? I can go through it quick, yes? Okay. If you just immediately look at this, if your eyes are drawn to this x minus y, these are equal. So if you try to do 2y plus 10 is equal to x minus y, now you're going to run into a borderline system where you've got two variables in the same equation. So see if you can avoid this. There's another little x sitting right here all by itself. If you could figure out the value of x, you could just do substitution right here. And then you'd no longer have two variables. So take a look at the upper triangle. If this is 40, 180 minus 40, that's how much you have left over for both corners. So how much is x? 140 split in half, 70. So x is 70. You can just go back over to this equation that we first started with and replace this with a 70, and then you can solve this for y. So I'll quick solve it if you want to just check your answer with mine. And then we're done. Sometimes you need one variable first. Sometimes it doesn't matter which variable you do first. You just gotta pick and choose, okay?